Hello guys, let's talk about quantum computers and what it means for a system to be quantum resistant. So you know that quantum computers, once made fully powerful, they could break most of the cryptographic method that we know today, especially if they use one like ECC, which is elliptic curve cryptography, and RSA. And we know that this method is used by your favorites, which is Bitcoin and Ethereum. And at the end of the day, these two methods, these two algorithms, they eat deep into generating digital signatures, encrypting. And you know that this plays a huge role when it comes to you having to sign a transaction. And when signing a transaction comes into the picture, you know that funds can be moved, right? So you can see how serious this is. But no, it's not the end of the world. You know, we've met cool inventions in the past, and it felt like we are all going to die in it, but we've been thriving. Even while quantum computers is coming up, there is also post-quantum cryptography, which means as quantum computers are coming up with the ability to break some algorithms, there are also post-quantum algorithms that are also being developed and worked on. So as quantum computers is coming up, once they are making it more powerful, we're also getting algorithms that can be resistant to it. And it doesn't really mean that quantum computers or is here to steal your funds and take your money. They are actually cool inventions that quantum computers is here to solve. So what it means is that as they are coming up with their invention, we are also stepping up our algorithms to meet up with the technology that they are bringing on. So doesn't mean that they are here to just steal your funds and all. They are cool inventions that quantum computers is here to solve. And some of it is, AI and ML, they are a huge thing right now. So quantum computers have a good role to play there. There is also finance, there's optimization. So there's a whole lot. There are things that the conventional computers cannot do that quantum computers can do. I also find them in drug and molecule simulations because molecules are a whole lot of things. So if you're in the medical field, you understand that this will help for more drugs to be known and to be how the molecules are interwoven and all. Quantum computers can help find that out, and also it's just basically going to lead into spiral of even more inventions because things that has been limited by the current computers that we have today would be able to be solved by quantum computers, which is a great thing, right? So it is led for us who are into the blockchain and also who have systems, because this is not just only about the blockchain. There are still algorithms that you use for your normal website for working in your back end that quantum computers can break. So it's very important that if you're a CEO, if you're someone that owns a particular system, it's very important that you know that some of these algorithms that you use for protecting your back end, are they quantum resistant? That is the question that you have to ask. And if they are not, then you should start looking into the post-quantum algorithms and how you can protect your system, because it means, when inventions come, bad actors will take advantage of it, definitely. And good actors will take advantage of it, definitely too. So it's just left on who is involved or who is in charge of anything to be able to protect their system, because it's going to empower both bad hackers and good hackers. So you don't want to be at the mercy of these guys. You also want to be able to do your own protection, and then we'll be fine, right? We'll be fine. So the words in the streets is that Stacknet is quantum resistant. And why is that so? Even though why some systems is waiting to be able to implement the post-quantum algorithms and cryptography, some systems today are already quantum resistant. And why is that so? Stacknet uses Stack, which is what it uses to generate proofs, which it sends to L1 and they do their thing, right? So the reason why this is quantum resistance is because it is based on hash functions rather than number theory. So hash functions like SHA-256, they are not vulnerable to quantum computers because they cannot be broken by Shor's algorithm, which is the algorithm that quantum computers can use to be able to solve the cryptographic math that is behind ECC and RSA. But since Stack is not based on number theory, it's actually based on hash functions, and these hash functions are not vulnerable to Shor's algorithm. This makes Stack quantum resistant. Although quantum computers can actually speed up brute force attacks on hash functions, but then for hash functions to mitigate this, they can actually do that by doubling the hash size, right? So in as much as it is resistant, it can also, in as much as it is not vulnerable to Shor's algorithm, it can also speed up the brute forcing. But then hash functions now have to also update. They need to up their game so they can actually increase the hash size, therefore making the brute force even harder for quantum computers. So you can see that, yeah, this is going to be interesting, and it's also going to break a whole lot of things, and it's also going to make more systems more stronger. So it's basically going to lead to a spiral of innovation and a whole lot of things, actually. And that's how we've been thriving all this while. So instead of being like, quantum computers is here to take our lives, is here to take our money, is here to do this and that, we should be like, quantum computers is here to bring more innovation, is here to help us up our game. In fact, it's here to push us up our game, because sometimes we need the push, right? So it's here to bring a whole lot of inventions in many fields, solutions basically in many fields, and not just the whole idea of it being able to break our algorithms and all. So yeah, that's basically it for quantum computers. And you can see now that it's not just about blockchains, it's also about anybody who owns a system and has a code somewhere that they've written for their system and is using some of these algorithms to work on their system. It means you can be attacked if your system is not quantum resistant. Once these quantum computers are made fully powerful, then you can be attacked. So if you've not started looking into it, then you should start looking into it. And that's it for today. And thank you guys for watching. And until next time, keep building and see you on the next one. Bye. Peace.